Hello, everyone, and welcome once again to Threat Thursday. My name is Adam Mashinchi, the VP of Product here at Scythe, and today I'll be walking you through the Maze threat. We're using the Maze ransomware CTI that we gathered, that we crafted here using the Scythe interface, and then made deployable via the Scythe community threats for all of you to utilize it and understand it for yourselves. So jumping over to the Scythe interface, we can see here the Scythe threat creation window. And if we scroll on down, we dive right on into the actions that we created for the Maze threat. Now, the cyber threat intelligence for Maze is kind of all over the place in that there's a lot of really specific details about it, specifically from a domain and an MD5 hashes and all the like you would expect there from a payload perspective. And there's also a lot of detail regarding some of the mail campaigns it uses, some of the memory things it does, and the way it plays games with processes. And although there's a lot of intelligence about the kinds of behaviors it performs, there's not a lot of explicit examples about the behaviors themselves. For example, it'll say something like gathers user information, but doesn't explain which commands were used or which methods were used to gather that user information. And so when we recreated it here in Scythe, we used a blend of not only the native Scythe modules to perform those actions, but also some just manual commands that we imported ourselves. So jumping right in, we go ahead and we are loading in the run module right into memory there, as we always do, which gives us arbitrary command line accesses. And you can see here at step 2, we fire who am I. And of course, as always, all of our commands are tagged with MITRE ATT&CK IDs. We then dive in and we load the sysinfo module, again, a native Scythe module that dumps the system information, same with processes, same with services, all of these discovery techniques that we know the Maze ransomware performs before it begins its operations. We then dump the ARP table using Windows APIs, and then we're doing a dir on the user's documents directory. We then dive into a little bit more tradecraft, which comes default with Scythe, specifically in the reference to this UPSH, which stands for Unmanaged PowerShell. And this is our ability to run PowerShell in memory without calling PowerShell.exe as if you would from the command line. And the first thing we do is dump some additional information about which AV is running, and then some network information as well, all firing in memory. Then we do some more commands, net use, stir of the C drive, and now we start to get into some more of the actionable intelligence that should light up some sensors on the endpoint. So we know that Maze does some stuff with the registry values and scheduled tasks for persistence and the like there. And so we just set some example data and then query for that data as a means of triggering those sorts of behaviors. Again, and this could be running happily in the user space or running as an admin. From a Scythe perspective, we don't really care because these are good things to be able to observe in a production environment. So after we mess around with the registry keys and some scheduled tasks, we then dump some more information like the host name, and then we invoke get date here, which is testing for T1124. And this is an example of us using something directly from Atomic Red Team, which of course we have tight integration with. Now we move on to the interesting stuff from a Maze perspective, specifically the ransomware part of the show. And in order for this to be production safe, but still trigger all the same behaviors as ransomware should, we're going to go ahead and load all of these capability modules in the memory, and then we're going to construct a directory in which we'll perform all of our adversary behavior. So for example, here we're going to create a directory on the user's desktop called xmaze folder. And then inside of that, we're going to put a malicious files directory. And then inside of that, we're going to drop a number of files that are both a combination of things actually utilized by the Maze ransomware and some ones that we've created as for an example. Now, one of those in particular is we're actually going to be dropping the decrypt-files.txt file, which is an exact copy of, an exact replica of the actual Maze ransomware note left on actual endpoints once they're compromised. And we're going to be delivering that directly from the Scythe virtual file system onto that endpoint. And so if in the event that you're signaturing based on that kind of file or its content, this should light up those notices. We then drop a number of PowerShell scripts and batch files that are actually utilized by the Maze ransomware. And even though we're dropping these on the endpoint, we actually have no intention of utilizing them. And so here we drop a number of things: FTP download, FTP upload, something called malscript, which is not actually a malicious script, but we're going to detonate it anyway. Then the desktop wallpaper that Maze actually sets your wallpaper to. and some other batch scripts here. And then we create a directory called xtarget files. And this will be where we're going to use the scythe module, the file module, to create, in this case, 10 5 meg files that are just full of random. And these will be the files that we're going to be performing encryption on. But first, we're going to head and actually just use the scythe search module to search for those files. Again, some more discovery techniques now that we know what our target files are for the sake of this production safe example. After we found those files, we'll go ahead and actually perform some compression using PowerShell, in-memory PowerShell again, on the files we want to exfiltrate, and then we will perform the exfiltration on our target files. Again, this is not only ransomware, but some extortionware as well that we've seen with Maze, and so this is the extortion part of the show. We then use the scythe crypt module to, in this case, perform that ransomware encryption on the original files, and then deleting the original ones. Then we echo the user profile in order to perform this command here, where we are performing a script. We're actually firing the script, that mal script that's just hello world in this case, the one that we created as a proof of concept to see if we could fire some PowerShell scripts from in-memory. We then load Mimikatz and fire that off, detonate it in memory just to see if we can, because again, there's some of the CTIs shown that Maze actually uses Mimikatz. And then we go ahead and run PowerShell.exe. Now, this is theoretically the loudest thing we've actually conducted in this campaign, where we're calling PowerShell.exe directly, no in-memory, no tradecraft here, and we're trying to set the actual wallpaper of the endpoint. And so theoretically, if anything's going to be noticed, it's probably this one. Now, if you've managed to not block anything that came before this, you might be kind of sad. But again, we wanted to just kind of announce, hey, we're going to change the wallpaper now. Let's see if you notice this. So once that's done, that's kind of the end of the threat itself. We go ahead and wait 10 seconds, and then we've actually added in some cleanup here to undo the things we've done. So we delete the registry key, delete the scheduled task, and remove that entire Maze directory, the one that we created for this engagement. So with all that said, and that threat kind of talked out based on the CTI that we gathered from Maze, we can actually see in Scythe the results of us conducting this operation. In addition to being able to see all of the operations we conducted in real time, we also have this report here. This is our high-level summary of all the MITRE attack techniques we tested for, and the red means we were successful with here in Scythe. That's just a one-click summary we can generate. And we can also, with a single click, generate our Attack Navigator report, which is the same output, but in the Attack Navigator JSON format. And as always, you have the ability to jump into the Scythe interface, use the migrate threats option to import and export various JSON files, including the Maze threats that we went ahead and created for you and put in the community threats place. Of course, we provided all the files you'll need to get going with that. And enjoy. Hopefully this helps you create a scenario in which you can test the Maze threat in a production safe way and see if you have any sort of behavioral triggers or defensive logs that would catch some of the behaviors provided by the Maze threat. Thank you for your time. Again, this is Adam Mashinchi, and I hope you enjoyed this Threat Thursday.